Hey guys, welcome back to my channel. Got a trick for you today called a different number. On the table here, I've got 10 little tiles, each with a different number written on it. There's one-digit numbers, two-digit numbers, three-digit numbers, odd numbers, even numbers, big, small, kind of a wide variety of numbers here. And what I would do is I would turn my back and I would let the spectator grab these numbers, pick them up off the table. They can mix them up if they're in their hand if they want. They can mix them up face down on the table if they want. And whenever they're happy, they're going to divide them out 5 for themselves and 5 for me. So the spectator, again, is making all of these shuffles and all of these decisions. Let's say they pick for themselves 1, 2, 3, 4, and 5, and these 5 for me. Whatever the spectator wants. So at this point, I would turn back around. And what we're going to do is we're going to each look at our numbers, and we're going to arrange them from our left to our right, smallest to biggest. So the spectator will take a look at their numbers, and they'll arrange them from their left, the smallest, to their right, the biggest. So we'll go 65, 104, 113, 252, and 273. And then I will arrange my numbers from my left to right. So 7 is the smallest, 28, 149, 190, and 218. So a lot of randomness just so far in terms of how the spectator mixed up the numbers and how they divided them out. But what has essentially happened here, if you look, is we've created 5 random pairs of numbers, one of mine and one of the spectators. So what we're going to do now is we're going to go through each of these pairs and we're going to calculate what the difference is between these two numbers, and we're going to write it down. So we can start on either end, it doesn't matter. We'll start over here. So 218 and 65, the difference there, I don't have my calculator, so let me calculate this in my head here real quick. That is, I believe, 153, so I'll write down 153. You can do the calculations at home yourself if you want, if you don't trust that I'm doing it correctly. 190 and 104, the difference there is 86. So I'll write down 86. 149 and 113, the difference there is 36. That's an easy one. 252 and 28, the difference there is 224. And then finally 273 and 7, the difference there is 266. So what we've ended up with is 5 very random, very unpredictable numbers right here. Now keep in mind, again, this is all dependent on how the spectator divided out these numbers. If they had mixed them up differently, you might have had maybe 104 and 28 paired together. The difference between these two is 76. So you'd have 76 on this list instead of one of these other numbers. So 5 random numbers, completely up to how the spectator mixed up and divided these numbers. Now the last thing we're going to do is take these 5 random numbers and add them up. So again, you can do this calculation at home if you want. Make sure I'm adding it up correctly. But I'm going to add them up here on the paper. That is a 5, it's a 6, and 7. So again, you can do this at home if you want. Our grand total after all that is 765. Again, if these had been shuffled differently, divided out differently, these 5 numbers would have been different. We would have ended up with a different grand total. But we've ended up, after all that randomness, at 765. But was it really random, or was it magic? See, over here on the table this entire time has been 3 playing cards. 3 cards whose values somehow correspond to 765. So that is the effect, you guys. It's called a different number, kind of a fun math-based trick. and I hope you liked it. So let me know your thoughts in the comments below. As always, I appreciate you watching, and I hope you have a wonderful rest of your day.